example using video capture. So I got the video turned on.
Yeah.
And we'll go ahead and I'll reconnect to my server. Appears to be working. Oh, good. We have a built-in hard deadline because it's only got 13 minutes of clock cycle left. So we'll start the program. It'll take it a few seconds. Oh, that loaded quick today. And oh, that's right. We're going to build it from scratch. So let's do it right. File, new. View, backdrop. We're going to take the backdrop from example 5 because it's already there. Okay, so there's our example, just like in the online book. So the trick to the pumps is we have to surround the pump with nodes. Those nodes are going to, in this particular case, going to be set at 3 meters above this water surface. If we take that water surface as a 0 datum, those would be at elevation 3. So let me make the notation. Okay, those nodes are created. Now we need the 2 reservoirs. So we'll have the lower one and the upper one. At the lower one, I'm going to set the total head to 0. At the upper one, I'll set the total head to 10. So that represents the lift that we're trying to achieve with the pumping system. There's my there's my 2 pipes. This lower one, let's go ahead and fuss with its appearance a bit. Yeah, I like that. Okay, so I drew that lower pipe kind of as a way to visually remind myself that this pipe is going to be 4 meters long. It's actually drawing from 1 meter below the surface in this reservoir. So let's go ahead and tell myself that pipe is 4 meters long, 100 millimeter in diameter, and a roughness of 0.1.
Can we change it?
Yeah, it worked better. And then this pipe, leaving the pump, is 100 meters long, 100 millimeters in diameter, and also 0.1 roughness height. Now we get the roughness height value. We looked that up on the internet or in a table. there's no realistic way that it's something you can remember or realistically figure out without having access to some reference material. I guess if you did a lot and use the same kind of pipes, you get pretty used to it. Our upper reservoir, I forgot if we... So everything's almost ready except what we don't have is the pump. So the symbol for the pump is this object right here. And pumps have direction. So it's kind of important that you set the direction correctly. If you make a mistake, you can still finish drawing the network. There is a feature of the link objects, which is if you right click, it gives you the option to reverse. And what reverse does is it changes the inside, the input side and the output side. It flips them. Okay, so we're almost set to go. There's our pump. Now, call your attention here since we're doing the video. I don't have a pump curve associated yet. So it looks like this particular model is ready to go. But there's no pump curve. So if I try to run it, I'm going to get an error message. It says the run was unsuccessful. See status report for the reasons. Oh, it's not going to show me this. I just crashed my program. There we go. I pressed the escape button and it says there's no head curve or power rating for pump 3. Multiple errors in the input file. Doesn't know what to do. So let's go ahead and hopefully I haven't broken everything. Let's add a pump curve. So in the browser dialog on the Data tab, I select the keyword curve and I'll click this icon, which is to add a curve. And now it's waiting for input for a pump curve. And if you recall, we already determined what the curve would look like. At 0, produces 15 units. At flow of 1, produces 14.9 units. And at flow of 2, produces 14.6 units. And you'll notice up here in the dialog box it now returns an equation of the curve we just supplied, and that's identical to what was in the problem statement. Now if we add more, the way the program works is actually, to the best of my knowledge, it never uses this equation, but it gives you a representation, an equation representation of the curve. It always uses the tabular values. It's how it's designed to work. So that pump curve is now staved, so let's store it. Now we go back to the pump and we have to associate a curve with the pump. So curve number 1 is the only one available. So now when we run the program, it should run without protest. So bear in mind what we did. We created a pump curve and then we associated the curve ID with the particular pump.
Yeah.
So if you had multiple pumps in the model,
Everyone will.
They can either all use the same pump curve, or you can have different pump curves for each pump. And what would change in those cases would be the curve ID. And the curve ID, you can give it the one pump. So I've just changed the name of it choose OK, and I don't think it'll automatically pick up that change, but we'll see. Yeah, it doesn't. So this has to, that should now associate the curve with a pump. For me, this was the hardest part of learning how to use this program, was the association of data with certain objects. We got run was successful, which makes us very happy. And in 3 minutes, the computer is going to log me off. So let's hurry up and look at the output. It should be showing 7.07, and we have one more change to make. I didn't change the units. So all the units we supplied were in SI. So let's make it agree with that. It should be liters per second. Darcy White's back. Choose OK. Rerun. Successful. So the answer should be something like, I think it's 6 liters per second. 6.47 liters per second. And if we wanted to save this, how would we do that? It's the interactive part. You need to tell me. You got 2 minutes or less to tell me how to save it. So I think you said go up to the File menu, choose Save As, and now we need to give it a name.
ICT Example 5.
I'm just going to take what you said and shorten it a little bit. So now we've saved our work. It doesn't matter if the computer logs me off now. Let me exit the program, and we will set up for rendering the next video. And then I always remember to exit the connection. And in principle, we have just done example 5.